Hello everyone, my name is Wahib Al-Jabri. I'm going to speak about my final project for Data 604, which about emergency room simulation. In this project, I focused on importance of optimizing patient flow and resources allocation in health care system by utilizing simulation modeling. I aim to improve the efficiency and effectiveness of medical facilities. The simulation specifically examined the dynamics of patient arrival, triage, and treatment in outpatient setting. By simulating the operation of medical facilities, we can access critical performance metrics like waiting time, treatment time, and resources utilization. In the problem and significance, the problem managing patient flow and resources location in emergency room is challenging during peak hours or with limited resources. Significance: this project aims to optimize emergency room operations through simulation-based resources allocations and improve patient outcomes. The flow chart, as you can see here, the simulations models the patient arrival and treatment process in a healthcare system. Patients arrive at a specific time or specific rate and go through check-in and triage. If a patient is critical, they see a doctor for treatment. Otherwise, they see a nurse. The simulation tracks waiting times, treatment times, and resources utilization. It adjusts the number of doctors based on demand and dismisses idle doctors. After running the simulation, performance metrics such as average waiting time, average treatment time, and doctor and nurse utilization are calculated. So the simulation setup, you can see here, first of all, I imported the required libraries, and then we wrote the code for the simulation, which we followed the flowchart. The simulation that I provided is a patient arrival and treatment simulation in a healthcare system. It models the process of patient arriving, check-in, being triaged, and receiving treatment by doctors or nurse based on their critical condition. The simulation collects data on a various aspects of patient service and calculates performance metrics such as average waiting time, average treatment time, doctor utilization, and nurse utilization. As you can see, after we run the model, we got some outputs for the patients. The results shown an average waiting time of the average treatment time means the result shows an average waiting time of 136 minutes, average treatment time of 11.91 minutes, doctor utilization of 29%, nurse utilization of 35%. The simulation provides insight into resources efficiency and can be used to analyze and improve the health system's performance. Through the validity and verification, during the development process of the emergency room simulation model, intermediate outputs were checked to ensure accuracy. The simulations report was reviewed to prevent overlapping service times between patients. Each simulation run served an expected number of patients, around 22 to 33, and other variables were tested to avoid unrealistic results. Although validating, validating the simulation model was challenging without available data for comparisons. The flow of patients and reported waiting time closely resembled real life experience in the emergency room, validating the model's behaviors, while empirical validation would have enhanced reliability. The simulation served as vulnerable tool for exploring and analyzing the emergency room scenario. Here is the graphs. First graph is the distribution of surface types, which represent the stacked bar chart doctor and nurse over time intervals. It illustrates the number of patients served by each surface during specific time intervals. As we can see here, the waiting time for each patient is increasing. The average waiting time, as we mentioned previously, is like 136. The average treatment time around 11 minutes. Doctor utilization 29 minutes. Nurse utilization is like around 35%. Here's the second plot is a stacked bar chart, the distribution of a surface between the doctor and the nurse. It illustrates the number of patients served by each served during specific time interval. So in conclusion, the simulation-based optimization of resources, allocation and patient flow in an outpatient setting, particularly in the emergency room, offers a promising approach to improve healthcare system efficiency and patient outcomes. By utilizing simulation modeling techniques, we can analyze and evaluate different scenarios, access critical performance metrics, and make data-driven decisions. The developed simulation model effectively captured patient dynamics, resources utilization, and key factors affecting patient flow. So the results provide valuable insights into waiting time, treatment time, and resources utilization, enabling healthcare administrator to identify areas for improvement and optimize resources allocation. So this simulation model holds a great potential in enhancing healthcare system efficiency and supporting informed decision making for improved patient care. Thank you for watching.